Hello viewers, I'm Kausalya. Today we are going to solve problem related with admittance parameters. So this is another method of solving the same problem. So here this is the given network. We are asked to find the admittance parameters. Now we are going to solve this circuit by using nodal method. Previously, we had solved by using the normal method, that is by short circuiting the input port, we will be finding two parameters, and short circuiting the output port, we will be finding the remaining two parameters. But here, we are going to find the values of the same parameters by using nodal method. So here, you see, the modified circuit is nothing but, you see, here we are having inductor, so the value is replaced by 2s, and in the place of capacitor it is 1 by 2s. It is always mandatory to do this. After doing this, here we are now fixing the nodes. So let this be your node 1 and let this be your node 2. A node is a point where two or more elements should be interconnected. But here in this case, we have to consider this side, that is this input port as node 1 and this port as node 2, and these two ports, they remain at the same potential. So here it is 1 and here it is 2. Okay, this is 2 and this is also 2 because they both remains the same. They remain at the same potential. So here this is our modified circuit as usual, V1, I1, and here it is V2 and I2. So this is the first step to be done, and this is your node 1 and this is your node 2. So here don't get confused why we are marking this point as node 1, because to solve this circuit it is mandatory to have two or more nodes. So here I have taken this port as node 1 and this as node 2. Right. So by nodal analysis, first we are going to write the equation at node 1. So when you look at node 1, a 2 ohm resistor is connected to node 1. And it is not only connected to node 1, it is connected between node 1 and node 2. So while writing the equation, you see here the current which flows through this node is I1. So I1 is equal to V1 minus V2 by 2. As we are considering node 1, here this should be given importance. That's the reason why here I am writing it as V1 minus V2. So I1 is given by V1 minus V2 by 2. So when you solve, I1 is given by, that is V1 by 2 is 0.5 V1. Okay, you can split and write V1 by 2 minus V2 by 2. So 0.5 V1 minus 0.5 V2. So this is your equation. This is your one equation. So when you compare this equation with the standard equations, what are all the standard equations? Here you see this is the standard equation. I1 is equal to Y11 V1 plus Y12 V2. Now I have an equation in terms of I1. So I can compare this equation with the standard one. So when you compare here, you see what happens? Here I am having I1, here I have V1 V1 and V2 V2. So in the place of Y11, instead of Y11 I am having 0.5. So Y11 is 0.5 more because here we are discussing admittance parameters. And the next thing is Y12. Y12, here it is minus 0.5. So Y12 is equal to minus 0.5 more. Right. So we have calculated two parameters, Y11 and Y12. The next thing is, now we are going to calculate the remaining two. The remaining two parameters are Y21 and Y22. So now we are going to write the nodal equation at node 2. So when you look at node 2, what are all the elements that are connected with node 2? So here again this 2 ohm resistor is connected and this inductor and capacitor is also connected. So while writing the equations, so here it is V2 minus V1 by 2, right? And here it is V2 divided by this combination 2s plus 1 by 2s. So this is what I had written here. So I2, okay, the current flowing through this node 2 is I2. So this I2 is nothing but V2 minus V1 by 2, because here we are writing the nodal equations for this node 2. Therefore, here we have to write it as V2 minus V1 by 2. Okay. So, this is your first part. Plus, and again to this circuit, okay, to this node, these two elements are connected. So, here it should be written as V2 divided by, and these two elements are connected in series. So, you can directly add. So, here it is V2 divided by 2s plus 1 by 2s. Now the next step is we are going to take LCM for this second term. So once LCM is done, what will be the expression here? 2s into 2s, 4s square plus 1 divided by 2s. Now the next thing is, again I am moving this to the numerator part. So here V2 into this comes as a reciprocal. So 2s divided by 4s square plus 1 into V2. Now I am combining the V2 terms together. So here I am having V2 by 2 and here I am having this entire term with V2. So once V2 is taken commonly outside, the remaining terms are 1 by 2 plus here this term minus this minus V1 by 2. Here it is written. Right. So here for this part again we need to take LCM because the denominators are different. So once you take LCM here, this is your expression, right? So 4s square plus 1, that is just cross multiplying. 4s square 1 into 4s square plus 1, 4s square plus 1 plus 2 into 2s, 4s whole divided by 2 into 4s square plus 1 minus V1 by 2. Now we had framed I2 in terms of V2 and V1. Now we are going to compare this equation with our standard expression. So what is the standard equation? I2 is given by Y21 V1 plus Y22 V2. Now when you compare, so we are having, first we will find Y21, right? That is coefficient of V1. So this is your V1. What is the coefficient of V1? It is minus 1 by 2, right? Therefore, Y21 is minus 1 by 2, which is minus 0.5 mho. Right? Is it clear? So here we are having V1 and here it is V1. So in the place of Y21, I am having minus 1 by 2. So minus 1 by 2 makes minus 0.5 mho. Again, when you compare the coefficients of V2, here I have V2 and again here it is also V2. So the coefficient is, here it is Y22. In the place of Y22, I am having this expression. Right. So here the value of Y22 is 4s square plus 4s plus 1, the whole divided by 2 into 4s square plus 1. Right. So this is your expression for Y22. So finally we have calculated all the 4 parameters. Right. So in the previous video I had solved by using normal method, and here in this video I had used the nodal method. Again it's up to you to select the method. You can select the easiest method for your comfort. Right. So that's all. If you have any doubt, let me know in the comment section. Thank you.